Baseline is pretty good. It's pretty good. I'm using these like little spoons to stir the coffee. I've like just like a long spoon. I think they're intended for like scraping sauce out of a jar or something. I love them. I love those small spoons. I have like 5 of them. Little itty bitty spoon. You're right. Yar. Okay. So much coughing. Would this? Okay. I guess I can actually test that. Would this conflict if I did that? Let's see. Merge. Who did this? It sucks. I was cleaning this up yesterday after the stream. I have so many little look at all my branches. I just go crazy. I I am not a clean git brancher. This coffee said it was supposed to be on ice. I didn't put it on ice. As long as it delivers the caffeine, I do not care. All right, I'm gonna make a branch. We're gonna go on top of this guy. Create branch. Yes, sure. And then merge this and see if it died. All right. So it just likes it. It's like, yeah. I thought it might conflict because of because of this, but no. This is oh, it was already done. Uh that's right. That's right. Okay, so I can just do it. Please. I hate how it like forces the cursor to go somewhere else. New pool request. Why is this so hard? Uh, we'll do like this. Can I add like tags ahead of time? No? Okay. Yarg. Wait, this is bad. I'm doing the DOM stuff again. I need to like just like put that off and do this. All right, MinDiff. All right, all right. We're not looking at that. Push solve. Yard. We're looking at this. Oh boy. Okay. 3 hours of this, and then make your pull requests and make it perfect. So why was I thinking? Right. I was thinking that it would not need lifetimes because the function could accept them. So I could just go like, oh, and then there's no such thing, and then there's no such thing, and then there's no such thing, and it's just all easy. And then there's no such thing. And then there's no such thing. Yeah. And then this would go like, oh, by the way, we got these meshes. What? Meshes? That's crazy. That makes it simpler. There's no like lifetime stuff and like holding references. Yeah. Answering messages. Golly gosh. Do you think the Pixel 10a will come out? Google Pixel 10a. Release insights. Early 2026. Without the overheating issues. Without the overheating issues. Arg. Arg. Focus. Algorithm. Convert. Lua. Rust. Welcome to Rust. We use Rust around here. Yarg. Dot product. Is it better to... Okay, who's doing more dot products? A dot norm. So we're not doing that. Direction unit. Look at that. So this is like redoing part of this calculation. Probably this is also redoing part of the calculation. Because there's a lot of math in there, but like we'll kind of ignore that. Yarg. I was kind of like staring at it yesterday as well. I did do a lot of stuff, but like it's still confusing. I don't have the algorithm figured out. I don't really know what it's doing. So I can see this main loop where it's like picking a next point based on the hint direction. So it's like find new points to explore. It does direction, negative direction. There's two meshes here. It's like, so what is this? Fart vert, farthest vert. You have two meshes. Maybe they're like this. And the old algorithm was doing these query functions. And what that does is it asks in a specific direction, what's the farthest vertex? So if I say this direction, well, the farthest vertex is the top vertices in that direction. And if we go like this direction, then now the farthest vertices are over there. And that's defining the entire mesh for the old algorithm. So it's like selecting a new point on the surface of the mesh based on a direction from the previous iteration here. Reduce simplex. So I'm wondering if there's 8 points here, and it's like, I actually have no idea. What the hell? How does that work? What is that doing? Yarg. Is this going to replace the original intention of infinity fev? This is not is this. Yes. Yes. Infinity fev. I also had another branch that I was trying to do that. I was just kind of making up an algorithm, but I realized that bhop already has an algorithm that does that. So shrimple. So I think I'm gonna. Oh, it's not a type. It's not a real thing. Yarg. Yeah, I'll keep it not a type for now, and I'll make it a type later if it makes sense. Okay. I'm gonna start doing some functions. Functions, I say. Yes. Do not full screen. Game. Very good. La 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 la. So yes, I'm wondering if this expand. Who uses decompose? Right. One, two, three. Choose any direction. Bow. All right, we have a lot of code to paste here. Yar. I don't really like the look of the slash with every line in Lua. It'd be kind of nice if I could like. I don't know what would be better than like just kind of writing lines. All right, I need this. Yeah. Some pretty big functions. Reduce simplex. I'm gonna move this so that. Oh, I did already. Oh. Ooh. Okay, I should actually be able to just grab this code here. And this is basically literally this function. Reduce simplex. And then is this a PQ? I don't believe there's any. Okay, let's see. No. Option? Does that make sense? Error, return. So what even does it return? Return direction. Can we return not direction? Is that possible? Looks like it's an infallible function signature. Yar. What is this? Oh. Yar. That's my new catchphrase for some reason. Sad pirate noises. Oh my goodness. So it's gonna be do like this. We have simplex No. We have PV3 and simplex. Yeah. So I can... Do I want to simplex? Maybe. I don't actually know. So I think it makes sense. Pass it in here. It goes... And then it makes a new one. So it's like stack allocated. So it doesn't super matter. He said confidently. Two. Zero. 0, 1, 2, 3. Can a simplex have 0 points? Shouldn't this be like 4, man? All right. Yeah, apparently this is not real. Whoa. Expected. Do I need to do like as slice? It doesn't just deref as a slice? So evidently all of these are infallible. 4. So it's not C. I guess I'll just like go like this and that'll work. So this is vertex, but I'll say it's a P. Looking in your eyes. I am not as good a singer as that guy. Ah! Sorry. ER. This is A, B, C, D. Help. So the first step here is doing the difference. But then also it does actually like have the original stuff somewhere, somehow, sometimes. Okay, let me take maybe take a look. Because I'm wondering, what if the actual points don't matter and I can just like always use references? So B0. Okay, does this ever swap between 0 and 1? 0, 0, 1, 1. It never says like 0 equals 1. It's tough. This is so the whole point of doing this is that this is going to be faster than the infinity fev thing. So if I make it slow, There was no point. I'm liking what I'm seeing so far. So I'm thinking about how it might need to redo work. So this is like not hard work, I guess. So it shouldn't matter. The hardest work is when it goes like this type situation. Sine over magnitude is unfortunate. Get to it, man. Start with the simple ones. So the absolute determinant, these have different somethings. Something. What is it? Dimensionality. So I'm a little bit curious. Abs det is used there. Okay, so it just immediately compares it to constant and epsilon. So I can avoid rounding it and do the comparison in the function. So abs det, I would wager that what's that's trying to do is determine if it's a empty space or a negative space. Okay. It's a parallelepiped, right? Parallelepiped. Yeah, this guy. So this guy goes like, there's like, gosh. Imagine the corner of it is here, and there's like 3 things coming off, and it's like changing shape. So you can imagine, like, what if one surface just goes onto the other side and like crosses over? Then it kind of turns into a negative area. And like that can happen in many different ways. But it has meaning. And that this is the determinant of a matrix where the matrix components are these directions, or the lengths of these sides, the vectors of those sides, gives you the area, the volume of the parallelepiped. And that volume can be 0 if they're all like laid out flat. It's very useful. That's what this is doing, I think. Okay, so yeah, I can avoid the square roots and stuff. So it's only used once, right? Abs det. Yar. Yep. Okay. Okay. Okay, so we're gonna I am not a healthy man. Direction dot product. The right hand side is next point. Position. I'm just making this up. And then simplex. A is the first vertex. 0 dot position. Something like that. And then we're doing if the dot product is positive. So if it's less than or equal to 0, then it's not positive. Or simplex, we could say like simplex det. Wait. Oh, abs det. Oh. Less than epsilon. Oh. Absolute determinant ER. I think I can do... do I have an unsigned abs? Oh, I'm actually writing code. This is great. Okay. Literally... Oh, gross. New point ABC. So this is already... okay, so this already wants the simplex to have this scoobert in the doobert. Because we got the new point and ABC. The new point ABC. So that means this code goes right here. So now we've modified simplex. ER. That's A. ER. We don't care about A before that. Oh, look. Look at what I can do. 0. Yar. Okay. Abs det. We can pass a reference to the simplex. LT epsilon. We'll say epsilon. Okay. We're gonna zoinky epsilon. Zoinky. The yoinky sploinky. You know what's pleasing to me? Scroll bars on Linux. So you know how on Windows, when you like click the scroll bar and then you like move the mouse far away, it goes and it like freaks out? Try it. It doesn't freak out on Linux. You can just move the mouse. I can move the mouse like all the way onto my other monitor, and it's like, oh yeah, you're scrolling. You're goddamn right I'm scrolling. You better goddamn keep scrolling because I'm scrolling. Why would it just like that? It's dumb. It's stupid. Windows is stupid. Rant over. Where's the epsilon? I thought I was using an epsilon. All right, let's F epsilon. There it is. Oh my god. Okay. That's a oof. All right, we'll start with a little epsilon guy. So 1 to bits shift right. Yeah. Fixed 4. I think we can do better than that. So let's do shift right by 10. Is that like an equivalent E? So if we do 10 to the negative 6 log 2, do we get about negative 10? I would assume yes. That seems like what I would do. Log 2, 10 power negative 6. Help, 10 to the power of negative 6. Oh! That's almost negative 20. That's a pretty big epsilon. Really? 10 biddies? Did I ever try it with 0? What if I try it with 0? Get out of here. Let's try it. Oops. Less than epsilon. Fixed 0. Oh, equals 2. 0. Oh, look. I have equals to fixed 0 in this one. I must have tried it. And it was like, or something. I don't know. Let's see. I'll grab it on the master branch. Whip, paste, friends, boink, and then boink, negative 20. Okay. We go to strafe, build, release. And then we go try. What map is that? Memorial. 2? Memorial. Give me the ID here. Memorial. Okay. Oh. Run. Surf maps. Yeah. Let's try Memorial 2. Yeah, okay. You good? Alright, this is the one I was thinking of. Okay, so does it like do weird stuff and like crash and like oh. Alright, it just did that. Alright, what if I go like, oh, I'm going in the corner. Okay, well it's not crashing. Let's try the main event. So this is a surf that goes down and it like has this like sweeping V curved shape. That's actually pretty hard to do physics for. And I'm wondering if it was relying on the epsilon or if it can actually do this. So let's see. Oh, okay. Well, it did it kind of after. Oh. No epsilon, huh? I wonder if that would introduce a new bug if I did that. That's where I would expect it to introduce a new bug because that's like essentially where this kind of thing would happen. Well, no, debt abs fixed. No, it would be like two flush surfaces, nearly flush surfaces. It'd be like something that's like a very low angle. But if it's not 0, the math should work. Because we're not clamping here. And we're returning a ratio. This should be exact. So let's try 0. I wonder if I just threw it in there because I didn't believe it could work without epsilon. So this would actually remove the epsilon entirely. No way. What happened here? Move on up. Oh, true. So true. Okay. Let's go to arcane and just do a run, I guess. Remove epsilon. Push. Solve. Remove epsilon. With a prayer emoji. No. Okay. Arcane. I'm gonna jump on the square. Okay. Well, I mean, yeah. There's bugs for sure. I love smooth gameplay. All you need is high FPS. Let's try like, ooh, that worked pretty well. Ooh, look at that. Go like this. All right. There's bugs, but like, you know, there's bugs. It's not like crashing or like doing something really bad, like teleporting you because you're like, because the calculation is wrong or something. I hope that's right. My goal is to like have no epsilons in the entire physics. So like in Roblox, I ended up needing to use like a thin skin around the hitbox and like all collisions to like safely always determine that a collision has ended or that a collision is starting. So like there's like a slightly inflated bubble around all hitboxes where it's like, oh, you're about to hit it. Oh, I know. And so instead of being like, maybe think of it like a light switch where like, there's light switches where like you can kind of like get it halfway and it'll go like click, 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 and it'll like flip on and off like rapidly. That's kind of what I was trying to avoid, where like there's not a point where it's sort of ambiguous whether or not you're touching it or whether you are touching it or not. You always begin touching when you enter the like thin skin zone, and you always, well, no, it'd be the other way around. You always begin touching when you touch the actual object surface, and then you stop touching when you exit the thin film skin. But really, this problem should be well defined. I should be able to just have no epsilon, no thin skin, and be able to just kind of do the math right and do the math exact. And the libraries I've been working on should enable that. So yeah, be gone, epsilon. Epsilon, be gone. Shocking. Okay, well, where's a map where you can like walk into a wedge? I mean, we kind of did that. Walk into a wedge. less than epsilon. Yeah, I mean, should be fine, right? Yar. What did I do? Didn't save that? Okay. Abs debt. All right, everybody. It's time to implement the abs debt. Where'd I put the function? I'll just leave it there, I guess. Okay. What did I call it? Function abs det less than ding dong simplex. Yeah, less than epsilon. Why don't I just do abs det is 0? Well, it's called less than epsilon. Then I can change it to is 0 if it don't be. Cool. Okay, so we have the old simplex. Simplex epsilon. Oh. Yeah, okay, I need it to be built in. I can't have an epsilon. Unlucky. Okay. Abstet is small. I'll just leave the less than epsilon. I'll change it later. I can't just pass the epsilon. Otherwise I need to convert. Oh my god. So then this guy goes here. Yar. And then this guy. Come on, bro. Okay. It's literally this. Hoi. Okay. We're doing the mash thing again. Please. Like this. Yar. And we're not doing reduce simplex. That is not what we're doing. Oi. Isn't that weird though? Absolute value. I don't know. Whatever. Okay. Rubbed. Yar. Whatever. Okay. Gosh. I'm like still sick. Okay. You are cringe. You are is. Oh, I actually need the real. I'll just write it out. Okay. P1 minus P0 cross real. P2 minus P0 dot P3 minus P0 Door. You know what? I'm just gonna say is 0. It's fine. Equals fixed 0. All right, nice and small. One is 0 is false. No way. Okay, so this is now P1 minus P0 cross P2 minus P0, right? V minus R equals vec3. No, not quite. It's a scoobert doobert 0. Do I have a triple double uber 0? Mega triple double 0? No. So we're gonna do new fixed 0. Const. I don't know, just like const. I don't even want to deal with it. Okay. And then this is also the same thing, except I can do equals to vec3 0. And then that's this case is 1 equals 0. So V U, if R is real, it returns 1. And it also does that there, apparently. So, okay. So these are Minkowski vertices. They don't actually have a real position. They're just kind of there. Who are you? Oh. Yar. Fixed. Self. I don't like that. Yeah, I don't really like the look of self. Looking at me funny. Okay. Simplex abs debt is 0. Right. Oh. Choose any direction. Why is it widen? Why is it so undefined. Erg. I don't like this. Oh, PU. What? So, yeah, this is a triple. Wait. Oh. Oh, yeah, I know what this is. That's right. But that's like, this is not great. It's some. It's the projection of P onto the U plane or something, but then multiplied by U twice. Voyage. Ah, the dimensionality, the dimensionality. So yeah, I'm seeing the pattern of like repeated execution where it's like I should probably calculate the point ahead of time and then it just kind of sticks around. I don't know, like it cuz it's like indexing several tables. Or is it just one table? Let's see. Fart vert. Oh god. Vert. Transform point 3 vert. Ew. Right. Okay, I remember. There, I was wanting to do a thing so that this transformation would end up at this size because they would be 32-bit, 32-bit, and then it would end up 64-bit instead of having to do this. You know, I talk big with like, oh, I'm going to make it exact. I'm going to remove the epsilon. But it's really hard. It introduces so much complexity, and you actually have to solve all the problems. You can't just kind of like squeak by with a little skin around the part. Yar. Okay, how about I just do it? And then and then I can simplify it after. I don't know if I should like Minkowski right away. It, you know, it's not that hard. I think I'm gonna Minkowski right away. So Minkowski mesh. That's right. You heard it here first, folks. Yeah, get out of here. I have no idea. So I will also need an offset here. I wonder if I can just slap it right here. That'd be real good. Because it's like minus, right? Decompose. Minus P. Oh. Minus P. A minus P. That's already... No, yeah, no, that does it. That does it. Damn, son. I think that this is this. But then that also means I need to do this. So this is mesh rel pause. Yeah, so direction. This is mesh dot hint point. Is it minus rel pause? Rel pause, I would define that as mesh 1 minus 0. So that should be plus rel pause. No way. So new point is just a Minkowski fart. Mesh fart. Oh. Is that not real? Can you really not do that? Private. God damn it. You good? What do you want? It is not private. I just made it public. Oh, it's trolling me. Okay. So we can then fart again. Right here. Bow. All right, it stopped trolling me. Very awesome. So now we have PQ. So this is going to be mesh dot vert. Yeah, like that. Right? And then yeah. So that's position. But then oh, you're subtracting 2, so it doesn't need the relative offset. So then okay, I change this to is 0. Holy moly. Is negative. Direction dot vert next point. Is it minus or plus? I think it's plus. Rel pause. I just have to remember to. Oh, I can do this, right? No. fart. No. Oh my god, bro. Oh my god. Okay. We're not using PQ anymore. Poggers. Work, I guess. I'm just gonna like say we're making progress. Goddamn private farts. Okay. I really want to make this into a type. Cause like it's looking good. I could put rel pause in there as well. This is gonna be tough because I'm introducing this like thing here. So like this is, it's like built in. Q, like Q has some position and P has some position, but I'm giving this relative position. So everything that looks like this needs to have plus rel pause beside it. And that's annoying. I think this is negative rel pause. Yar. What happened? Why did it only do one of them? Oi. This is gonna be a lot of work. Oh my god. The sickness. Okay, mesh, Minkowski. Do I also need this? Reduce simplex. Is that what I'm doing? Cross. Okay, I've got goobers here that are all deltas, differences. So I think it's chill. So we say, what's up? I'm a Minkowski, Mike Wazowski. And then we calculate P0, P1, P2. And then we do the calculation. What happened? Oh, const. Yeah. I'm just going to say that out loud. Const! Let's see. It's 0. I'll just call it 0. PV 128 0. Oh god, now I have to say the type. I have to say it out loud. Vector 3 of fixed freaking like 264, I believe. Goob. Okay. Is that really? Yeah, I don't know. Okay. Let P0 equals mesh dot vert. P0. 1, 2, 3. Wow. And then I go like this. And that does it. Wow. This should be const. Does 1 equal 0? No. I might just say false. All right. All right. Wow. So once again, this is doing it's like redoing this, right? Again and again and again. Oh, is this a fast path for this? I guess not. Yeah. Holy moly. Uh, mm, uh, mm. It's really hard to like dig in and make progress. Cause like I'm unsure of the best way to do things. That's why. Why? Oh. Hmm. I'm. Oh, now I'm curious if this actually. What happens? What is this algorithm if it's not operating on a Minkowski mesh? Farthest vert. Hint point. Is this equivalent to point inside part? I don't know. If I make this generic on the mesh query trait, it would be different, but the same. I think it is just the distance from the mesh. And that's equivalent to yeah, no, it is equivalent. It's so like having the Minkowski sum where it's like the two meshes summed together, and then you find the distance to that to a point of that like larger mesh. I believe that's equivalent to just like moving the other mesh to the point and finding the closest point between the two meshes. So that's a cool thing I hadn't thought of before. That came from the fact that this looks like it will be generic across the mesh query trait once there's const generics in Rust. I'm gonna heat this coffee. So you may notice I went off camera. The probability of reappearing with cheese on this stream when I go off camera is extremely high. Cheese. Mm-hmm. Doesn't go well with the cheese. Coffee and cheese. That's pretty amazing. That's a good insight. Cheese. Oh, yes. Oh, I've never seen it do that. Hmm. Gotcha. Crack it open. Oh. Oh, jeez. Oh, yeah. Damn. That was good stuff. I'm pleased with the insight I got today. Or like 5 minutes ago, I guess. Where um if I make this operate on a Minkowski mesh, then it's equivalent to just point in. Is this point in the mesh, or what's the distance to this point from the mesh? And that's equivalent to asking, what's the closest point of approach between these two meshes when the mesh is a Minkowski sum of those two meshes? Hmm. Hmm. Oh. Oh, radius times. Yeah, no, there is no radius. Amazing. Hmm. Hmm. So the main algorithm is pretty juiced. I just need the like detail math. Hmm. 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 Um, I'm not sure if I'm going to need the expansion math. Where did it go? It's like right here. So this is expand, and that's a massive algorithm. That's the majority of the code is this function. Um, mm-hmm. Hmm. So I actually don't care what the actual values are. I think I want to have like 3 stages. I guess I can implement it with 2 functions. So, the first stage just tells you whether or not it actually intersected. Num num. And if that's the only information you need, like that's point in part. Simple as that. And that is extremely useful. I've needed that algorithm. But then it also can say which surface was closest. But then it can also say, I don't know why I highlighted this. This is irrelevant. It can also say what the exact points are on that surface. So that's like 3 layers of details. That's why I'm sort of calling this details. I think that I will not need the details. And that I only care about which surfaces. Hmm. Okay. Be right back. One more bite. Take it away. More cheese. No more cheese. Enough. Well, I still need to implement the algorithm. Yar. Really cool. Simplex stuff, and it's a simplex of a Minkowski sum. Where's the wacky stuff? This is where the wackiness happens. I can't stop like staring and wondering if there's a better way. I really need to do more busting out code. I wonder if the compiler makes the indirection go away. Oof, excuse me. Probably not always. Oof. So, yeah, I don't really know how to do that. And I don't really need this information. So I do need this information. Why? Why? Expanded. So decompose ABC. ABC. I think what this is doing is just kind of like digging further into the mesh because the actual closest point, it knows it's intersecting somewhere, but the actual closest are not intersecting. Something. My headphones are not working. Okay, is this? Oh, it's an AI. Not a fan. Go away, I'm working. All right, just start writing some math. It needs to be made one way or another. So, choose any direction. Oh. So this is a little bit tough, but I'm just gonna tough it out. function choose perpendicular direction. UV3. I suspect that these will go away in the end, and I'll be able to use pure topology. Yeah. Okay, so XYZ min square. That's a one-to-one function, so it's absolute value. So we want Lex. Let real. So absolute value. Why? All right. It's I think that this will go away. Can we do xyz dot min ord? Oh, whatever. I'll just min x min y min oi. Oh, oh, is that gonna pattern? Already. Oh, true. So I believe I'm going to be hitting this. Okay, good. I made a function. Great job. Make another one. Ooh. Oh. Oh, obviously. Oh no. Okay. It's not a reference, is it? No, it is not. It is not. It is not. Is this gonna be good? Is this helpful? Does this am I good? Is this helping me? 0 oh, direction. Oh, so I'm gonna do mesh. Minkowski mesh, and then go mesh. I'm gonna name this something else. This is P0. It's actually like the topological vertex. So there's the vertex position and then the like vertex ID. I don't know. I'll go with V. Call it a day. So that means all my P's have to be V's here. Whatever, I'll just do it. Okay. V. Simflex. Yar. It's moving and stuff. It doesn't need to. Do I just inline the bodies and make it one big ol' function? Would that make me happy? I don't know. And you're just kind of supposed to know. Length. Okay, so like it is an array, so the bounds checks should be omitted. I would be shocked if they weren't. So I just have to match the length, and then return the simplex. So what okay, what happens in this one? B1 is it ever swapped? Okay, so it's only truncated. Okay, what about this one? So we got full swap truncate. B equals C. Okay, and then what about number 3? So full swap truncate. Okay, I'm seeing it. I'm seeing it more clearly. Yeah. Okay, so I'm going to do this over the whole thing. So instead of as slice, I'm going to do .len. And then that's what's up. So we'll do it the other way around. We'll go 0, 1, 2. 0, 1, 2. So choose any direction or something. Why would you say that? Shut up with the underlines. Okay, so I'm certain direction simplex. So it always returns the same one. Mesh vert simplex 0 p0. Yeah, and then so it owns the memory, but it's still a panic. Arg. Maybe it still is good to match. I don't know. I'm just going to write it like this for now. Okay, direction equals negative P0. And then if direction is 0, then direction equals choose any direction. And that's it. That's the whole algorithm. And that is misspelled. Oh my god. Okay. And then, oh, you know what I can do is I can say like, ooh, this is like this. And then I can say like that. Maybe it's better like this, actually. Did I say return? I didn't. Thank you. Okay. That it just like blows my mind that they underline everything. Do it, 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 do it. Should I do it inline? Probably should. Yeah, that's way cleaner. Okay. Follow the pattern. P0, P1. Yar. And then we have P equals PU. Okay. We'll do it. I'll bite. All right, I'm really worried about the units and how that'll end up. Okay. Oh my god. Please. Oh, it's gonna need to be mutt. That's okay. So keep going, keep going. Crap. Oh no, it's you. Okay, we're good. We're good. We're good. All right. Obviously, and then obviously. Okay, so we go. Nothing has changed. And then otherwise, like that. So it's not quite the same. Let's just choose any direction. So we're looking for this. Oh. So it's going to be like this. And this is obvious. But this is perpendicular to you on both? Is that real? What do you want? What do you mean 3? Oh. Oh. Okay, we'll do a return here because it's a little bit complicated. So this is not clamp. What are my options? I have clamp, wrap, and Jesus. Narrow. That's right. Right, and that has a narrow error. Future? What? Okay, something is trolling here. I think this is beautiful when there's spaces in between the when there's comments. Computer. like, this is what I should have been doing yesterday, but I just am trying to think if there's a better way for some reason. Just do it, man. PUV. Oh my god. So U is B minus A. U is B minus A. Okay. V. Okay. Okay. Okay, let's see how this goes. This can get bad. Let equals to something. So U cross V. There's no such thing as, oh no, that is, okay. U cross P. P cross V. UV dot UP. UV dot PV. Okay, so now this is like a mega uber huge number because we've done quadruple multiplication or two multiplies. So now the number is 4 times the size. It doubles every time we multiply. Okay, so now we have an if statement. If of is negative. What is wrong with this? Why is it and? Okay. Greater than or equal to 0, which means it's not negative. And the is also not negative. Then we have our opening statement. Why would you do that? Oi. And we got here, question mark, question mark, question mark. Oh no, another dot product. Ah! Oh. Yeah, no, it's fine. Okay, ABC. Simples. No, we got here. Who made me write all those spaces? VV. Dot magnitude. No. Dist min dist 2. Dist equals min dist 2. Yeah, they have to be compared. Square root. Very bad. Very do not want square root. Oh, this is a pop, isn't it? Oh, not quite. We still gotta swap. Pop it and swap it. What the hell? Oh, pain. Mental anguish. Square root. Square root. Not the square root. Oh. Okay, so look. We got U, and V here. And U, and V here. So we're looking for the P-ishness of the dist. So it's like, why is there like halfway power? So, okay, what if I cross multiply? Basically, there needs to be the same number of U's and V's in both of these. Right? Yeah. Okay. Hurt. Okay, so we're going to do sure. Actually, I think I have a method for that. Whatever. I'll just write it like it is. Okay, so then dist UV up times VV times V length. And then V dist is UV PV times, oh, it's U, and then UUV. So this is still equivalent. I've just cross multiplied instead of divided. Meow. Can I get another U in here? Yar. So if vdist is less than udist, then we do this. End is obvious. Yar. Okay. Okay. Simplex. Let's see. AB equals simplex C. And then this junk. So, okay, so this is obvious. This is obvious. I can just put these together. Wait. I'm not a big fan of the mutable. It's not using it. It does use UV. Does it use UP down there? Okay, it does. Ooh, woo. Sorry. So, this is unused. Okay, look at this. 1, 2, 3 U's. 1, 2, 3 U's. 1, 2, 3 V's. 1, 2, 3 V's. So I can't add one more U to the top and one more U to the bottom without ending up with square roots. Can we take away? No. We need those square roots. Need the square root. Need the square root. Squared square root unchecked. Feels bad, man. It's not exact. Okay. Okay, so these are not the beautiful. They're not mutable. Why would you make them mutable? Just don't. Okay. Up. U, V, U, P, and U. I'm so sad. Is it you? Yeah. Like, brother, Alright. PU. Don't we already know that though? Cause like, oh, we don't. Oh, okay. Okay. Yar. Greater than equals 0 is if PU help is negative. If it is not negative, then it is greater than equal to 0. won't be having any of that. Oh my god. Up you. Up you. It's a new calculation. Alright. Direction equals up cross you. If we need the Scoobert. This is the simplest way I know to write this. Like this other one, this is worse. This is better. Ish. Yeah. Okay. Can you I don't know. It doesn't matter. Doesn't matter. Direction equals to scoob on the doob. Oh. I think that's a problem. Because this is a 3. Because we got 1, 2, 3 multiplies. And then this is just 2 multiplies. So this is actually a different number here. Different type. So return UV narrow unwrap simplex. Yeah. Oh my god. And then this one is direction narrow unwrap simplex view. I don't actually know if these are gonna work yet. They might just be too big. Who knows? Nobody knows. I could just like make it huge and it would be fine, probably. It's huge. So direction equals UV. How does this happen? So it's like exactly this, except completely different. So, bow. Wait, A0, A0? Is that a bug? I think that might actually be a bug. Yo. Oh, it's not this. What am I doing? So that's a crossing of the separate meshes. I think this is actually a bug in bhop main right now, and maybe even in Phantom Forces. Code review. And we've never seen it happen because no one looks at this code because it's so complicated. And the case is really rare. So you have to be reducing a triangle, and then it has to not encounter this condition, not encounter this condition, and have the like most degenerate fallback condition, which never happens. So it's like wrong, you know. Oh my god! I think I'm gonna go fix that. Who is this? Let me think. Is it Stephanie Mills? Yes! Oh! What the hell is that? Um. How do you like convert? So there's some like goober jank going on here where it's like, oh, we don't have CRLF Windows, and I'm not very pleased about that. Whatever. Okay. Fix bug in. Mesh points never cross over to the other side. Mesh 0 points should stay on. Go to mesh 0 and mesh 1 points only go to mesh 1. Uh-oh. Okay. Good. My lady. Special lady. Mm-hmm. All right, all right, all right. Ooh. Goofy, silly, 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 goofy. Yeah. Nope. Why isn't it laying like that? Uh-oh. Why is it... What? What do you mean divide is greater than 0? Oh, with the sign. Oh my god, bro. Oh. I'm fading. I almost... Okay. Shh. You are not as good of a song. Why did you do this, Trey? Direction 0. Oh, it's because it's gonna always... I see. So the direction doesn't matter here. That's why it's like this, is because it's like, oh, we got it. We got it. We got it. And it'll always like exit. If I recall correctly. Let's go look at the algorithm. So it's like direction simplex, reduce simplex. So next loop. If the length is the final length, then we'll return. So yeah, that's what's going on. It's kind of a weird signaling mechanism. I feel like you could probably like shuffle this around and like use a different sort of signal, like optionals, or I could have like enum with different lengths. So instead of an array vec, I could actually have an enum with 4 different lengths, and match against that. I will consider that, because that would be very, very, very explicit. It's a good idea. I'm gonna write it down. To do, consider using an enum. Because that would get rid of the this match thing where it's going matching against the length. You would just always know. You would just know. It only ever subtracts. Oh, how do you mem copy overlapping? I actually don't know what would happen. It doesn't matter. I could like flip it around and no. It would be fine. I'll let the compiler figure it out if I do that. Okay. Okay, why did that not happen? Go like this. All right, I'm tapped out. The manually converting Lua code to Rust and like trying to ignore my wants to like make it better and just like make it exist and then look into making it better. No way. It's a bug. Bug in the code. See? I'm like pretty confident about that. I'm gonna if you knew about this, you could probably work backwards with great difficulty and intelligence and engineer a map with a corner somewhere that if you touch the corner, it like bugs you out and does this bug. And it like depends on which meshes it is, and it like will like go to a different position on the other mesh, and then do the wrong thing and teleport you to the end, and you have a secret glitch. And it's in the game right now, but like that it looks very difficult to exploit. I have no idea how you would exploit that. I don't really know what any of this means. Well, consider it the idea. Oh yeah, no, I could totally do like push front as well. Where? All right, it's time for the pull request. C-frame identity. Yup. Add. Adds a convenience method to RBX types C-frame. Construct identity C-frame. So I need to add a documentation. Sure. Let's go see about that. Let me look at past pull requests. Yeah. Tie. Oh, it's sorted wrong. Why is it not sorted by recent? Alright, this one has one, I think. Alright, so you just say like this. Unreleased changes, change log. Oh. Added. So what's the number? Nope. Yeah. Let's see. Update change log. Real. Surely that's all. Okay. I did it. Yes, sir. How do these run before the build? Doesn't it need to build and then test? How are the tests faster? Oh, is this the tests? I don't know. Whatever. Okay. Oh, did I code in small today? Oh yeah, I did code in small. I didn't increase my screen size. Oops. Harder to see. I'm making the library better. At least that's my intention. I'm introducing noise. Ugh. It's not a method, it's a constructor. Tags, labels. I'm not allowed to add labels. Bruh. Oh my god. Sure. I'll just go with my stuff. Cool. All right. Good job, me. Gosh. 3 hours of work. Amazing. I really did do work, didn't I? This was... which one was today? 12 p.m. 21st. Huh? 21st. Friday. Thursday. Okay, so it's from here to here. 376 new lines of code. Tough algorithm. I don't know if I'll even be able to get it out. Or I'll be able to make it, but I don't know if I'll be able to extract the topological information. No, I should be able to extract the topological information. It's just sourced from the farthest vertex. So I would need to do this kind of goob stuff. Yeah. Probably this can be simplified. It'll take some brain power though. And I am fresh out of brain power. I can't end the stream yet. I need to like reach 3 hours of streaming, and I'm only at 2 hours and 47 minutes. Boss says there's 10 more minutes of work. Work. What can I do? How did I get so tired so fast? Is it the coffee? I'm doing work though, so I can be as tired as I want as long as I get the work done. Tired as I want. It doesn't matter if I am tired, as long as the work gets done. Oh, crazy algorithm. The enum is so interesting. It's probably good. I think that it will have a very minimal performance impact, and the algorithm is probably just going to be high performance because it's not doing a crazy number of multiplications over and over and over again, like the fev crawl, infinity fev crawl. So like it's just a robust algorithm that can set everything up from scratch. I don't know why. I'm really glad that I found that I thought to reuse this algorithm because it's already there and I can just convert it like this. I don't need to make and debug a new algorithm. I have a very heavy head start. Thanks, Trey. Bootstrapper. What? Did the work. The work got did and done, and I did it. Friday. I'm gonna end early by 8 minutes. Oh, I missed one day, but I did work every other day. It's not unprecedented for getting back to work. It's happened before. I think I have the best method to getting rid of the falling through the floor bugs, and that is to adopt this algorithm from Roblox bhop, adapt, port. This algorithm is exactly what is needed. I just didn't know that it was. It's also generic across mesh types, where operating on a Minkowski mesh, it's equivalent to finding the closest point, the point of closest approach between two meshes. So like the if there's like two meshes, it'll like find the line that connects the two meshes the closest. And if there's only one mesh, it's finding the closest point to a point outside the mesh. And these are actually equivalent problems when a Minkowski sum mesh is involved, which is something that I learned today. I figured out. And this algorithm can do both. It can do intersection test. You can test to see if two meshes are intersecting. You can do point inside the mesh test, which is equivalent. So I'm going to definitely try and make it generic across the mesh query trade. It could be a little bit difficult, but that would be extremely useful. I would be able to replace a lot of slow and buggy code that depends on the crawl algorithm, the infinity crawl. Fantastic. Brilliant. I'll probably just put it onto the mesh query trait itself, because it's literally a mesh query. Is this point inside the mesh? That sounds like a mesh query. Amazing. Yeah, I'm going to treat it like you're doing a point test. Is this point inside the mesh? But then also use it for the algorithmic setup, which happens to be the same thing. Yeah. Okay, I'll be back on Monday. Hopefully I continue this, because this seems like a very direct and reliable way to solve many problems with the physics. Great. Oh, wait. Oh, Twitch says I have 10 seconds, and then I'm over 3 hours. Three, 2, 1. Whoa, 3 hours of work. All right. Goodbye.